I think we can start this afternoon section. And so welcome to the afternoon session. We are dealing with ecosystem biodiversity and protected areas, various parts of the world. So it's a very heterogeneous session. And actually I will start the first presentation. We're talking about lakes. Just we have a small technical issue here, but okay. So well, I'm going to start and see if this works. Yeah, great. So the first slide, couple of slides just to remind the problems of water. I will deal with lake and long-term monitoring. And we already heard about a lot about lakes and the level of water and the problem of water. But of course, despite there are a lot of water in the world, very few is available for human use. And so there are a lot of problems with increasing scarcity. We already this morning section dealing with glacier, retreat of glaciers. So the amount of water is reducing due to several factors like population growth, changes in living standard, and pollution, and climate change as well. And so this is one of the issues that are related to water. But this is not the only one. The other one is very important. It's associated with the quality, because we don't need the water, but with a good quality to assure the possible use or different use of the water. So especially for humans, we need a very good quality of water. So it's not a matter of amount, but it's also a matter of quality. And I will show you some examples of why it's important to study these very tiny lakes in the mountains. To convince you that it's useful. And this is small lakes because they are not so important as a volume, but they are very sensitive. And so they are replying quite early to different drivers and forcing factors. So they are usually taken as early warning. So they can be used. Studying lakes could be this kind of lakes. It's important to have an advanced information of what will happen in the future, could happen into this kind of environment and to the water quality. So there are many different forcing acting on those lakes, and these lakes reflect the impact of different pollution like acidification and deposition of organic pollutants, heavy metals, and nitrogen inputs, and climate change. These are the four major drivers. And I will give you a couple of examples that I've been working on from the Alps and from the Himalaya itself. So the Alps, it's easy to show the impact of human beings because they are the Po Plain, that is the most heavily industrialized area in the North Italy. They are moving, transporting of a lot of pollutants to the mountains. And so this changes these lakes, producing in particular acidification. And this was a problem in the past that was partially solved. And here you can see the value of having a lot of information in terms of sequence. And, so on the left lower side, you see the pH value, so the amount of the acidity of the lakes from 1984 to 2012. And this is progressively increasing. So the pH is increasing. There's a change in pH, increase in alkalinity. And this is due to the impact of a reduced pollution in these lakes. So we have a very severe problem with acidification rain. Maybe you remember there was a huge issue of acidification rain around the 80s, 90s. And since then, there was a lot of a program to reduce pollution. And these lakes can trace back the improvement. So we have both signal, the worsening that was in the past and the improvement that is, you can trace what happens in following the new regulation, the reduction of pollutants in the Alps. And of course, you see on the center part, the sulfate decrease, that is atmospheric deposition, and the pH increase. So we have the opposite trend, so a good recovery of the lakes following the protocols of emission reduction. So this is just to show you that these lakes are sensitive to what happens in the surrounding, and they respond to what is happening. But of course, not everything is positive. We have other kind of lakes in the same area, where you can see on the lower right side, where this is what happens with the reduced snow cover and increase in conductivity. So it's increase in the amount of solute in the water, because what happens, the catchment is less covered with snow, so more reactive. There are more chemical process, more weathering and degrading process in the soil, so more input to the lake. So they are increasing in concentration of the solute, amount of minerals dissolved in the water, due to less snow cover. So they are responding to what we know this is a climate change impact, one of the negative aspects of the climate change. So these are just to use some idea what can be recovered, what kind of information can we get from this kind of environment. And you see this in this specific lake, we have information for 1934. So it's a very long series, and this is the importance of having a very long series to understand the changes, because we often talk about changes, but then we need a benchmark to see what was the situation before. So this often is a problem, because we don't know what is the situation before, because the problem we realize when we realize the problem where there is a problem, and it's not always not easy to understand it in advance, to have enough information to understand what are the effects of the problem that we see now. So the importance of this long-term trend information is relative. And so this is an example from this we call a pyramid lake, because of the pyramid laboratory. Actually, they are at the base of Mount Everest in the Khumbu Valley. And here again, we have done several approaches, several studies on these lakes. One, so the show here is the dynamic of these lakes, comparing the position and the evolution of the lakes in the area of the Sagarmatha National Park. So within the protected area of the Sagarmatha National Park is a monitoring of the distribution of different lakes based on satellite imaging and on ground truthing of this information, because often you see a lake on the satellite map, but then you have to go there and check if it's really a lake or just a mistake. And again, here we have a good time series, and you can show the response of the lakes, the positioning of the lakes. They are moving, they are shifting according to the melting of the glacier. So melting glacier means formation of new lakes. And so the lakes that are in the lower area, in the lower altitude, they tend to disappear. And when new lakes are forming at a higher altitude. So this dynamics is possible to detect only when you have a time series information. So this again is the importance of these things. And also here in this Himalayan lakes, we see the same trend that we see in the Alps, connected to the climate change. That means an increase, you see on the left side, an increase in alkalinity, an increase in the solute amount because of the reduced and more active process in the catchment. So this results in a more increase in the ionic solution, the amount of minerals dissolved in the water, because the catchment is more active. The catchment is more active because there is less ice in the catchment. And finally, I'll just a quick show. There was the last one I would like to show is another opportunity that offer the lakes. It's a really long term. You see this 1,000 years and 1,500 years history of the lake that could be recovered from the sediment core that's similar to the ice core. They can use it to trace back what happens into the lake. So we can go really back in time and have information on what happens in period where we have no data, because nobody was thinking to go to the lakes in 1,000 years ago. So this is another opportunity offered by this kind of studying of the lakes. And so the final, just to sum up, is just to show you that lakes respond to change in atmospheric deposition, because these are very small lakes, very small catchments. So the process of what happens in the atmosphere quite quickly reflect what went into the lakes. The same process are going even in larger lakes, but it's more difficult to highlight because they are more process mediated by the catchment. The catchment is much wider, and so there are much more many processes going on at the same time. Here you have the opportunity to see what are happening in the atmosphere and how this reflects in the lakes and into the water. And so many drivers related to climate is important in this kind of lake. And well, finally, this long-term monitoring is really needed, and this is really challenging to keep a good quality of data for a long time, because that means often going with the people to analyze the samples, and so a lot of manpower is needed to sustain a long-term data with good quality data, because we want to see the changes, so we need to compare data collected 10 years ago with data collected today. So we need a good comparison, a good track of what happens in the process, because it's not simple just to analyze the samples, but to have a good quality to ensure the comparison between different years and samples. So this was, I think, was what I will say. And so thank you for the attention.